Hello everyone, welcome to yet another webinar from SQL Maestros. My name is Amit Bansal and I am going to be your host and speaker for today. Quick introduction about me. I have been working with SQL Server for many years now. My core area of expertise is SQL Server performance tuning and query optimization. I primarily do two things. One, lot of consulting work, and again my area of work is SQL Server performance tuning. I fix server performance, I fix query performance, I try to identify root cause of bottlenecks and then tune queries and store procedures, etc. That's the first thing that I do. The second thing is all the learnings that I get from my real world projects, I package them into learning solutions. So I create masterclasses, I create video courses, webinars like these, YouTube videos, etc. All of that is available on sqlmaestros.com. A lot of that content is free and some of that content is priced as always. Anyway, so this webinar is all about configuring SQL Server for better performance. And again, just like a lot of other webinars, our content focuses a lot on internals, architecture, and performance tuning. And that's why I choose this topic about SQL Server configuration. Now, before we move into the demo, the content, and what we're going to talk about in next 60 minutes, quick housekeeping stuff. First things first, there are a lot of links in the chat window. If you wish to stay connected with us, which means SQL Maestros and myself, we are available on LinkedIn, on Facebook, on Twitter. There are a couple of groups like on Telegram and LinkedIn as well. So whatever your comfort level is, make sure you subscribe to or connect with us. That's first. The second is about questions. Throughout the session, whenever you have a question, please put them in the Q&A panel and I will answer them as we proceed with the content. Third thing, I get a very common question each time, which is this webinar going to be recorded? And the answer is yes, the webinar is going to be recorded and it's going to be made available to you. So let me quickly show you the webinar section on sqlmaestros.com. Let's just go ahead and minimize this. I am on sqlmaestros.com and we have a recorded webinar section here. Let's click on this and open this in a new tab. And when you come to recorded webinars section, you will be able to see a lot of webinars here. As far as I remember, at least all the webinars that I am delivering this year are recorded and are being put up here. Many webinars are free and a couple of them are very nominally priced just to make sure that we keep running this show. Now you may go and subscribe to individual webinars here, the free ones or the priced one, and you get lifetime access to the content. Now, if you really do not want to take the pain of going and subscribing to each webinar individually, you may just become a member on sqlmaestros.com. So the first link here on the menu bar says join. So if you click on this, let me just quickly explain you. If you join SQL Maestros and become a member, what do you get? So the first membership level is free, right? You're paying $0.0, nothing at all. As a free member, you get access to all the video tutorials, which is our demos and SQL Server tutorial content, and all the free webinars. The moment you become a free member, you can go to the video lobby and you can see there is something called as free content there. That is where you will be able to see all the video tutorials and all the free webinars. But if you want access to our premium content, which is advanced SQL Server content, tutorials and demos and all the paid webinars all packaged into a single membership level, you can opt for the premium membership level. When you do that and go to the video lobby, there is another option there called premium content. So you have a lot of options there. You're just interested in one or two webinars that kind of suit your learning objective, go ahead and just subscribe to that. If you feel that there's a lot of these webinars that are good to you and you want like all of them, go for either free membership or you can choose premium membership. Okay, so that answers all the questions about the recordings and the recorded webinars and the content around those. All good. All right, so topic for today, configuring SQL Server for better performance. I have 3 precise demo. In fact, the third demo has 2 more demos inbuilt into that. So we are going to talk about cost threshold of parallelism. That's the first one. Then we are going to talk about max DOP, which is maximum degree of parallelism. And the third one will be about memory options like minimum server memory, maximum server memory, and lock pages in memory. So precisely, I'm going to show you 5 configuration options at the instance level. So this is important to call out that these configuration options are not at database level. Anything that you change in these ones, these 5 ones that I talked about, will affect the entire instance. And there is a reason why I chose these 3 to kind of start off this series of configuring SQL Server for better performance, because I'm sure many of you know that when you install SQL Server, immediately after installation, you're doing a couple of things. All of you have your checklist, right? And I'm sure at some point, right on the first page of that checklist, you have CTP, max DOP, and a few memory options that you configure. This is all about that. Okay, so as I look into this Zoom attendee list, we have more than 200 people that have joined today. Okay, that is very motivating and overwhelming. I hope the content is worth your time. So let's get started. Let's dive right into the first demo. The first demo is about cost threshold of parallelism, also called as CTP. So let's go into this folder, open up the SQL file, and let's get started. Let's close this Object Explorer. Okay, before I talk about this option and what it does and what it has to do with the parallel world inside SQL Server, let's run a query. We're going to use AdventureWorks 2016. I'm going to turn on the actual execution plan or press Ctrl M. And here is a very simple select statement. You are pulling out some data from sales order detail and you say order by line total descending. Now let's go and execute this query. And within 2 to 3 seconds, the execution completes. Let's jump over to the execution plan. You get about 100,000 rows. And when you go to the execution plan, you can see that this is a parallel plan. Now, first thing, when we say parallel plan, we are kind of technically incorrect because a plan overall is not like a serial plan or a parallel plan. We basically mean that this is the execution plan and it has parallel operators. So you can see these operators like clustered index scan and compute scalar and sort, etc. They have a serial version as well as parallel version. Now you probably already know that these iterators, have this icon, right? Like the circle with this yellow circle with these black arrows, which means that this is the parallel version of the operator. And of course, because this is a so-called parallel plan, you also have additional iterators there in the picture. Okay, we are not going to jump into the parallel architecture of SQL Server, all the parallel execution. What we want to understand is, for such a simple query, SQL Server decided to execute this query in parallel. Now, when I say a simple query, what do I mean? I mean this query is inexpensive. If we take the cursor over the select operator and look at the cost of the query, where is the cost of the query? Here it is. Estimated subtree cost. You can see the cost is 4.3 or something. Now, whenever you are measuring something, there has to be a unit of measurement. Unfortunately, this number does not have any unit of measurement. It's just that the query cost is 4.3. Now, of course, going by the experience, and I'm sure all of you have also seen a lot of different execution plans, and you know that you get huge numbers, big numbers, and this number is very small. So what SQL Server does is, whatever is the cost of the query, SQL Server decides that this query should run in parallel. Now, if I take the cursor over clustered index scan and right click and go to properties, just want to figure out how many threads have SQL Server deployed here. Expand this actual number of rows and let's zoom in to show you that SQL Server decided to use 8 threads to execute this query. Now, why 8 threads? Because the laptop, the VM on which I am running this demo and SQL Server is running, has 8 logical processors. So what SQL Server by default and automatically does is aligns one thread to each processor and runs your query in parallel. So in simple terms, it means that when the query is running in parallel, it is utilizing all the processors, one thread aligned to each processor. Now, couple of questions. First question is, why does SQL Server parallelize this inexpensive query? That's the first question. And the second question is, even if it does parallelize it, where is the problem? Because I'm sure we all have heard that if your query runs in parallel, it's a good thing. It's not a bad thing, right? Multiple resources are coming together, trying to execute this query and trying to finish it faster, right? So let's answer the first question, which will lead us to the second question. So the first question is, why does SQL Server decide to parallelize it? Okay, so let's straight away jump into the configuration option. And this is where the first instance level configuration option, CTP, comes into play. Cost threshold of parallelism. This means that what is my threshold? Threshold must be some number that beyond that number, if the cost of the query goes beyond that number, SQL Server will decide to parallelize it. And if the cost of the query is below that number, SQL Server will continue to run that query in serial fashion, which means only one thread. As simple as that. So if I simply run sp-configure cost threshold of parallelism, let's just select this much and execute, you will see that the current config value and the run value is 5 units. Now, this is a very, very low number. If you have ever got into the world of parallelism in SQL Server, and if you have read a few things online, you would realize that this value is a very low value, and it was set way back about 20 to 30 years back in early versions of SQL Server. And since then, it has been continuing that way. So one of the first and foremost best practice when you install SQL Server and immediately after installation is to go and change this value to a more reasonable value. But let me first explain you all the computations that go behind this and all the comparisons. Now, SQL Server decided to run this query in parallel, obviously because the cost of the query would have been more than 5. But do you just remember, I took the query, I took the cursor over select operator and it was 4 point something, right? I'm sure you remember that. So it's not more than 5. But remember, that is the cost of the query when you see the parallel plan. We want to see the cost of the query when it is a serial plan. So what I can do is, just to show you, I can use a query hint called maxstop, and I can say option maxstop 1, which means using this query hint, I'm forcing SQL Server to run this query in a serial fashion, which is with just one thread, right? One logical processor. So let's just go and execute this. Jump over to the execution plan to show you what is the cost of the query when it was serial execution. Okay, there you go. Now you can see by the visual look of the execution plan that there are no parallel operators. Take the cursor over select here, and now you can look at the cost of the query, which says 10.4. Okay, 10.4 units, whatever. So this is what happens behind the scene. The optimizer will first evaluate, compute, or whatever it does. It will do with the serial plan. So it first produces the serial plan. It sees that the cost of the serial plan is more than the cost threshold of parallelism, the CTP configuration value. And it sees it's more, so going by that logic, it will produce a parallel version of the same plan or for that query. This is what really internally happens. So now I see that the threshold is 10.4. The default value is 5. And that is why SQL Server decides to parallelize the execution of this query and produces a parallel plan. So that answers the first question, that internally how this configuration works. And this is instance level configuration. Anything you change here, which means if you change 5 to 10 or 20 or 30 or 40, whatever, it will affect all your workloads. It will affect the entire instance. Okay. We get the answer for the first query. Now, if you have questions, please keep them coming in the Q&A panel. Now, the second question is, Well, if it parallelizes the query, where is the problem? And why should we really worry about that? Now, my point here is, and I'm sure you must have thought about this a couple of times, is when an inexpensive query like this gets parallelized, it really does not offer enough benefit to you. Now, we are only not going to look at the estimations from the plan perspective, but you're also going to look at the actual runtime statistics whenever you're doing query tuning, which is the reads that it does, the CPU time, and the overall elapsed time. You're going to look at those numbers, but we are not going to get very deep into that because then we will go into query tuning world and whatnot. Let's just stick to the topic as to what is the problem if it parallelizes. This is a very inexpensive query. This could have run absolutely fine with just one thread also. But then, because the configuration value is so less, SQL Server parallelizes it and assigns 8 threads to it. Now, just going by a simple logic and common sense, a task, any task, will not execute faster just because you assign more resources to it. If a task is very simple, just one individual can complete that task and can do that very quickly. Adding more resources to that task is more resource consumption, but the real benefit in executing it faster may not just come. The same logic applies here. This query, a simple select statement, order by something, is not very expensive. So assigning 8 resources to it, 8 threads to it, does not yield any good benefit here. It's just not about 8 threads, friends. It's also about the fact that my laptop, my VM here has only 8 logical processes. If you take this query and run it on any box you have with more processors, let's say 32 or 64, SQL Server will scale up and will actually create 32 or 64 threads, depending on the number of processors that you have to execute this query. Now, does it really make sense for this query to execute with 64 threads? Obviously not. 64 is the limit, at least whatever I read last in the latest versions of SQL Server, that when SQL Server parallelizes this query, any query, it can go up to 64 threads, provided there are 64 processors. So a query like this doesn't make any sense for this to get parallelized. Now, we were talking about this general concept of throwing up more resources. Now, gathering more resources, creating more resources, allocating work to it, and then completing the work, and then deallocating the resources. All of that requires more resources from the SQL Server engine, which is about memory and CPU, etc. So think about that you are a manager and there's a very simple task, and would you put 60 people to do that task? Now, choosing out 60 people, assigning the task to them, and then allocating the resources, then deallocating it is a whole lot of work to complete a very simple task. You might as well just complete it very quickly with one individual. Now, if you apply this logic back again to SQL Server, there is another problem. SQL Server has limited resources. Yes, it has limited resources. It does not have infinite number of threads. If you go into another discussion about SQL Server threads and worker architecture, you would probably read and learn that depending on the number of processors and 64-bit or 32-bit systems that SQL Server is running on, it has a finite number of threads. Now, if you are running on a box with 64 processors and you have 10 such queries, inexpensive queries coming in, and each one getting 64 threads, we are talking about 640 threads being consumed in a jiffy, right? Now, if SQL Server has maximum threads, right, it has a limit, then you are consuming so many threads for such an inexpensive task. You may put SQL Server in a thread starvation situation. Thread starvation situation is a situation where more tasks are coming in and they are waiting for a thread to be assigned to them. I know when I'm talking about this is not a very, very common scenario that you will see in SQL Server, but then it is not very uncommon also given, large production deployments and, where SQL Server is dealing with lot of users and under very heavy workloads. This can happen where you have so many threads, typical OLTP chatty environment, chatty workloads. They come, they quickly execute and go away, and you have all these threads running in parallel. There could be a thread starvation situation where your task, your request is actually waiting for a thread to be assigned to it. Okay, so what I did was here answered your question as to where the problem is, why you may not want to put too many threads, too many resources for an inexpensive task, and if that actually happens, how it may lead to thread starvation situation. So in all goodness, it makes sense that queries like these should not be parallelized. And I also want to give you a flavor of it. And I just want to prove what I am talking about, just not theoretical, but a bit practical also. Now, this is the query that will run with 8 threads. And this is the one which you just saw will run with 1 thread. Let's see what the optimizer thinks. So if I select both of them and I execute this, jump over to the execution plan. Okay, both of them are running. Okay, so there you go, they complete. And now let's zoom in and see the first one runs with 8 threads and the second one runs with 1 thread. And what does the optimizer think? The optimizer thinks that, okay, the first one should go faster. So the relative cost is 29%. And for the second one, the relative cost is 71%. Fair enough. 8 threads versus 1 threads. The optimizer thinks that the first one is going to be faster from a cost perspective. 29%, 71%, I just want to be technically very correct in sense that just because the cost is less doesn't mean optimizer thinks that something is going to run faster. It's the cost of the plan, and these percentages come from that perspective. Whether the query has actually run faster or not, then we need to get into actual runtime statistics. But right now I'm not getting into actual runtime statistics because, friends, both of them actually take about 2 to 3 seconds. So there is no noticeable difference. And I want to do that once more. Okay, so just take a quick look at it. I know I can turn on statistics time and all that on to show you actual numbers, but doesn't make sense right now because it's very, very quick. So let's go and execute this. Okay, wait for 2 seconds and it's done. Look at the status bar there. It takes about 2 seconds. Fair enough. Let's run this with 1 thread. The previous one ran with 8 threads. This one is running with 1 thread. How much time does it take? Okay, look at the status bar. It just takes about 3 seconds. Now, if you see, the difference is 2 or 3 seconds, but if you actually go into milliseconds, it will be very, very minute, very, very tiny. Okay, so what the optimizer thinks that, okay, comparing both of them, one is 21%, the other one is 79%. Okay, whatever, 29 and 71. Now, look at the trick here. I am going to change this to max.4. Okay, I am going to ask SQL Server, what do you think? If I run this query with 8 threads versus running this with 4 threads, is there a performance difference? Let's go and execute both of them. And let's ask optimizer what it thinks. Jump over to the execution plan after both of them have executed. And you will see 50% and 50%. Now the optimizer is pretty happy, at least from the cost perspective, and tells you that both of them are equally good. If you take the cursor over cluster index scan for the second one, I just want to show this to you that this one has been allocated only 4 threads, right? Max top 4. And of course, the first one is with 8 threads. If you just want to see this once more, let's go and do that. No problem there. Okay, there you go, 8 threads. Now, this rings some bells here, right? Because I get to think as a normal SQL Server, developer, DBA, architect, whatever that, well, if SQL Server knows that with 4 threads, the query is going to run equally well, why does it assign 8 threads? It could just assign 4 threads, save on some resources. Maybe those threads from the thread pool can be used for other requests, for other tasks. Why does SQL Server have to give all of it? Point to be noted. But the parallel architecture in SQL Server does not allow executions in that way. So you get the number of threads, one aligned to each processor, unless you are changing these options like max dop, at instance level, or query hint, etc., which is actually our second configuration. But let's come back to this one now. Now I'm going to run this again. I'm just going to look at the status bar, 8 threads. We know that this was 2 seconds. So there you go. You see 2 seconds. And now let's run it with 4 threads. Let's see how much time this takes. Okay, I'm going to just close the properties window and again 2 seconds. So earlier, remember with one thread, it was about 3 seconds, but now both of them are 2 seconds. Okay, point is we are all good with one thread. We are all good with one thread. So let's come to the conclusion. The conclusion here is inexpensive queries like these should not be parallelized. They're all good to run with one thread. So what you should be doing is, instead of playing around with these query hints and match drop, etc., the idea is very, very straightforward. Change the value for this threshold to a more reasonable value. Right now, the default value is 5, which is a very low value. And it is very popularly known that you should go and change this to anything like 30, 40, 50, 60, etc. Put any reasonable value and then keep fine-tuning it, right? Keep fine-tuning it based on your workloads, based on your baselining, based on your observation, how things are going. A lot of metrics have to be recorded. If not a lot of, at least some metrics have to be recorded for you to ascertain what is the optimum value. And you might just keep fluctuating it a bit. So that's the discussion we cannot have right now, but let's go and change it to something like, let's say 30. Okay, let's change it to 30 and then reconfigure. Okay, now this becomes the default value. Parallelism, let's just go and verify this, that now the config and the run value is 30. We are all good. Now let's go and run this query. Will it get parallelized? Of course not, because now you have increased the bar, you have increased the threshold. So let's go and execute and then quickly verify. Okay, this executes with one single thread. Let's jump over to the execution plan and you get the serial plan. Let's take the clustered, just take the cursor over this and quickly verify. Go to properties window, actual number of rows, and all threads just means that one thread. And you can see the cost of the query here as 10.4. All right, configuring SQL Server for better performance, for optimal performance. Very, very critical. Cost threshold of parallelism. Immediately upon installation, make sure that this configuration gets its right value. Okay, questions can continue to come in the Q&A panel. And while questions are coming in, let me just take a moment to introduce you, or just to make you aware of another thing on SQL Maestros, which is the master class. We have a deep dive masterclass, 40 hours, which is coming up in the month of December. And of course, you're watching this recording sometime later. There will be more schedules later coming up. So right on the home page, you have this SQL Server Performance Tuning Masterclass live class, or you can go to masterclasses, upcoming masterclasses. So either click learn more here or go here. And just take a moment to explore that if you are someone who wants to dive deep into SQL Server internals, architectural, troubleshooting, performance tuning, and query optimization, then this could be a right fit. A lot of details there. 40 hours online class. We divide it into 4 hours each day and 10 days, which is 2 consecutive weeks, Monday to Friday. All those details are available here, but most important is the outline. So if you look at the content outline from module 1 to module 14, we cover the length and breadth of SQL Server architecture and performance tuning. It is focused on core database engine. Very good for developers, DBAs and architects. CPU, TempDB, IO, memory, query tuning, index tuning, baselining, benchmarking, extended events, new features of SQL Server from performance tuning perspective. Everything gets covered here. So take a look at the query content. One of the biggest highlight is if you register for the class, you get to attend live, and the entire class is recorded and you get access to the recordings, and you get to keep the recordings for a lifetime. Yes, you get access to the recordings for a lifetime, which means you can just go and watch the recordings anywhere, anytime, and as many times as you want. This is for the community. So this is a real good deal. So yes, if you are one of those who loves attending live classes, live Q&A, a lot of demos, interactions, etc., and you get access to the recordings also, it might be something worth looking at. That is SQL Server Performance Training Masterclass, everything available on sqlmaestros.com.